Hello everyone. This week we're going to talk about the concept of elasticity. Elasticity is a property of supply and demand curves, and understanding it helps us get at some very fundamental economic questions. But before we really dig into that, I'd like to give you a brief outline of where we're going. So first we're going to start with price elasticity of demand, because it's kind of the most straightforward, moving directly on from there to price elasticity of supply. And the last elasticity we're going to look at in this chapter is income elasticity of demand. It's a little different than the other two, but it lets us get to some really interesting economic ideas like inferior versus normal goods and Giffen goods. And finally, I'm just going to wrap up by talking about how elasticities may change over time. So let's get to one of those fundamental economic questions. Does increasing the price of a good increase revenues for the firm that sells that good? And there's kind of two forces at play here, right? On one hand, the firm is going to make more revenue for each unit it sells. But also, it's got to take into account the change in behavior of demanders. Because, as we saw in the last chapter, if the price of a good increases, people demand less of it. And so if a firm increases its price, it may actually experience reduced revenues. And price elasticity of demand helps us address this question. So if a demand for a good is price inelastic, then increasing the price of that good will increase revenues for the firm. So what does that mean conceptually? Well, demand for a good is inelastic if a change in price has little effect on the quantity demanded. Some examples we could think of here are like healthcare, right? So EpiPens is a very recent example from, I believe, last year, where the price of it was increased and people just simply need them to be able to survive an allergic reaction. And so if the price of the EpiPen increases, people are not likely to change their consumption patterns very much, so the firm stands to make a great deal of revenue by increasing the price on it. Similarly, if we're talking a kind of more historic example, a society that primarily persists off of agricultural goods and there's not a well-developed kind of food supply chain, if the price of wheat increases, at a certain extent, people are not able to reduce their consumption of wheat because they need it for biological subsistence. Some other examples of price inelastic goods could be goods for which there is an addiction, cigarettes being a classic example. So, these are all ways in which the price can change quite a bit, but demand does not change very much. There are some few reasons why demand for a good might be inelastic. There could be very few close substitutes for the good. The good is something people need rather than just want. As I mentioned, consumption of the good could be addictive. And also, demand may be inelastic because the cost of the good might be very, very small. For instance, if, a pack of gum goes from, this is an incredibly anachronistic pricing of it, but from a quarter to 30 cents, it's not going to affect your consumption of it much because the difference in your overall budget is not going to change all that much for that increasing by 5 cents, even though it's a substantial increase in price based on percentage of the original price of the good. So the other case is goods for which demand is price elastic, and that has the opposite definition. Demand for a good is elastic if a change in price has a large effect on the quantity demanded. So, fast food is a classic example here. If the price of pizza goes up, people will just quickly substitute to other foods, tacos or burgers or whatever. And demand for a good can be elastic for a number of reasons. As I just mentioned, there could be a number of close substitutes that you could easily switch your consumption to. If the good is merely wanted rather than needed. And finally, if the cost of the good makes up a large part of the buyer's budget, that buyer might become very sensitive to changes in price of that good. So for instance, if rent goes up a huge amount. People may shift to living into smaller apartments because they can't afford the larger apartments with the rental increase. So we've talked about it conceptually, but we can actually measure price elasticity mathematically. And the equation for price elasticity demand is just the absolute value of the percentage change in quantity demanded over the percentage change in price. And we call this E. Over on the right-hand side there, you see the percent, and the little triangle is a delta, which just means change. So the percent change in quantity demanded is how you read the top of that, and the percent change in price is how you read the denominator of that. And then below there, I've got the equation for percentage change, where it's just new value minus base value divided by base value times 100. All right, so let's do some examples of calculation. So right here is an example of the most incredibly simple elasticity calculation I might ask you. Suppose that when the price of cars increased by 10%, the quantity demanded fell by 15%. What is the price elasticity of demand for cars? Well, if we look back at our topmost equation there, we need to get the percentage change in quantity demanded, divide it by the percentage change in price, and take the absolute value. So the percentage change in quantity demanded is 15%. So 15 divided by the percentage change in price, which is 10%. Take the absolute value of that. So positive negative sign on this really won't matter since we're just taking the absolute value. And if we divide both top and bottom by 5, then we're left with 3 over 2. And already taking care of the absolute value. So 3 over 2 is 3/2, which is greater than 1. So we can say that demand for cars is price elastic, since E is greater than 1. So this would be the most simple example I would ask of you. Here's a little bit more complex one. So at a price of $5, people demand 100 burgers. Suppose the price increases to $8 and people now demand 50 burgers. What is the price elasticity of demand for burgers in this example? So this adds an additional step. We'll have to use our percentage change formula here, right? So let's just write this out step by step. So we need the percentage change in quantity demanded over the percentage change in price, and we take the absolute value. So the percentage change in quantity is simply the new value minus the old value divided by the old value. So the new value is 50 minus the old value, which is 100, divided by the old value, which is 100. And then we multiply that by 100 to get a percentage. And similarly for price, we take the new value, $8, subtract the old value, $5, divide it by the old value of $5, and we multiply by 100. So as you can kind of clearly see here, the multiply by 100s cancel out. So we don't even need to include those in those calculations. I just wanted to show you why we don't have to in this example. So moving on from there, we've got 50 minus 100, which is negative 50 over 100. It's all still in absolute values. And then 8 minus 5 over 5. So 8 minus 5 is 3 divided by 5. Now we can simplify this fraction a bit further. I'm going to move down here. So we've got 50 over 100, which is the same as 1/2. And then our 3/5 in the denominator, we can just simply multiply by the reciprocal. So that would give us 5/3. And our 1/2 is still negative because we haven't done away with our absolute value yet. And this leaves us with 5 over 6. dropping the absolute value as well. So 5, 6, which is less than 1, E is less than 1, which implies that the price elasticity of demand for this good is inelastic. And so that simply means that whenever price increases, demand changes by a smaller percentage than how much price changed. One more sort of example I might ask you to solve. I'll give you a table that represents a demand curve. And so here we've got, consider the demand curve for shoes represented by the table below. What is the price elasticity of demand when price changes from $20 to $10? So in this case, $20 is our base value, $10 is our new value. So this is new and this is base. And those are each going to have corresponding quantities associated with them in the table. So at a price of 20, our base quantity is 100. And at a price of 10, our new quantity is 400, right? Just by referencing the table. And so we can calculate this just like we did in the previous example, except for we're pulling our values from a table. Percentage change in quantity over the percentage change in price. And this is all equal to the elasticity represented by a lowercase e. So the percentage change in quantity is the new value, 400, minus the old value, 100, divided by the old value of 100. And we're going to just drop the multiply by 100 because we know it will cancel out. And then the percentage change in price is from $10 to $20. So the new minus the old divided by the old, 20. Simplifying that further, we've got 400 minus 100 is 300 over 100. It's all still an absolute value. And then we've got 10 minus 20, so that's negative 10 over 20. So negative 10 over 20. Moving right along here, that gives us 3 over negative 1/2. We also think about that 3 as just a 3 over 1. So multiplying by a reciprocal, just like before, we've got 3 over 1 multiplied by the denominator flipped. 2 over negative 1, all an absolute value. That leaves us with 3 times 2 is 6 over negative 1, which is simply equal to negative 6. But now, sorting out the absolute values, we've got 6. And so E is greater than 1, which implies that demand for shoes, when we move from a price of $20 to $10, is elastic. And let's do one more example just for good measure. So what is the price elasticity of demand when a price changes from $5 to $10? So here, our change in quantity is from 500 to 400. So the new value is 400 minus 500 over the old value, which is 500. And for prices, our price begins at 5. So 10 minus 5 divided by 5. And just calculating all this out, 400 minus 500 is a negative 100 over 500 over 10 minus 5 is 5 over 5, which is the same thing as 1, so we can simply drop that denominator, leaving us with negative 100 over 500. And at that point, we can just simplify it down to 1/5. And so elasticity in this case is less than 1, which implies that at least over this other part of the demand curve, demand is inelastic. Having calculated those a little more formally, let's talk about the technical definitions of pricing elastic demand and price elastic demand. A demand for a good is price inelastic if the percentage change in the quantity demanded is smaller than the percentage change in price. And so this means that the elasticity value that we calculate is less than 1 after we take the absolute value. Similarly, demand for a good is price elastic if the percentage change in quantity demanded is larger than the percentage change in price, and equivalently, the elasticity value is more than 1 in absolute value. But there's kind of a midpoint between there, and that's unit elastic demand. The percentage change in a quantity demanded is equal to the percentage change in price, so numerator and denominator are the same, so it's equal to 1. So the elasticity value is equal to 1. And all that means is that if price increases 1%, then quantity demanded is going to fall by 1%. So there are also two extreme cases, that first being perfectly inelastic demand, represented by a vertical demand curve. And in that scenario, the quantity demanded does not change at all when price changes, and so the elasticity value is 0. The other extreme example is perfectly elastic demand, where any change in price leads to an infinite change in quantity demanded. And so this simply means that if the price were to increase by a single penny, demand for the good would disappear. Both of these are examples that don't really appear in reality. There are some contrived examples. For instance, your demand for medical services might be perfectly inelastic if you're having a heart attack, or your demand for a completely undifferentiated good, like say wheat in a commodity market, might be perfectly elastic because you could simply buy from a different seller. But these two extreme cases really just exist to help us orient our thought about what lies in between. So another important aspect of the price elasticity of demand curves is that even a linear demand curve has different elasticity values as you move along it. It's not like elasticity is the same thing as slope. Here I want to demonstrate how the price elasticity of demand varies along a linear demand curve. You may have noticed this in the past example I did, but I wanted to do it more explicitly here. So I've got a demand curve. Q is equal to -1/2 p plus 10, and I've already charted out 3 points on that demand curve. Price of 14, quantity 3, price of 6, quantity 7, price of 4, quantity 8. And you could plug in those price values and calculate the quantity values yourself if you like. I've also got them kind of graphed over there. So let's calculate the price elasticity of demand moving from a price of 14 to a price of 6. So, and then we'll calculate from moving from a price of 6 to a price of 4. So our elasticity is equal to the percentage change in quantity over the percentage change in price in absolute values. So we need, for percentage change in quantity, we need, well, let's start with price. So it's the new value, 6, minus the old value, 14, divided by the old value. And the quantity values that correspond to that are 7 minus 3 over 3. And that's all still in absolute values. Chugging right along there, 7 minus 3 is 4, so we've got 4 over 3 times the reciprocal of what this bottom ends up being, so 6 minus 14, so that's 8 over 14, so, or negative 8 over 14, but we take the reciprocal of that, 14 over negative 8. It's all still in absolute values. So 14 times 4 is going to be, so that's 28 times 2, so 56 over 3 times 8. So replace 16. So that's going to be 24. And let's go ahead and drop the negative, take the absolute value. And so we could simplify this further, but the essential point here is that this is greater than 1, which implies that demand is elastic over that interval of the demand curve. So if we kind of draw that in there, see, this is elastic. Now let's calculate moving from a price of 6 to a price of 4. So let me draw kind of a line here to separate that. So same formula as before. Percentage change in price, let's start with that since it's a bit easier. New value is 4 minus the old value is 6, divide by the old value, which is 6. The corresponding quantities are corresponding quantity for 4 is 8 minus the old quantity, which is 7, divided by the old, which is 7. So we end up with 8 minus 7, which is 1 over 7. And then 4 minus 6 is negative 2 over 6. There's still a fraction bar between those. Taking the reciprocal of the denominator, we have 1 over 7 times 6 over 2, but the 2 is negative. So multiplying that out, we get 6 over 14. And we can drop the negative because of absolute value, which is less than 1. And so it is inelastic. And so over this interval here, let's use a different color. Over this interval here, demand is inelastic. So that just demonstrates that even over a linear demand curve, some portions of it are inelastic and some portions of it are elastic. So returning to our outset, what does elasticity tell us about the relationship between revenues and prices? As you can see in this diagram, if we think about price being on the vertical axis and number of books demanded on the horizontal axis, our equation for revenue, price times quantity, is equal to the area of the rectangle that lies below the point that we lie on the demand curve. And so we can see that moving from this point here to this point here, we give up the area B, but we gain the area C. And so because area C plus A is bigger than area A plus B, we know that total revenue has increased. And so that price increase has increased revenue, which also tells us that over that segment of the demand curve, demand is price inelastic. Otherwise, revenue would have declined. So this chart just briefly summarizes a few of those things. So if elasticity is equal to 0, it's perfectly inelastic. Between 0 and -1, it's inelastic. But remember, we take the absolute value. So it would be a +1. I just kind of left the negative here so I could readdress that. If it's equal to 1, it's unilastic. If it's greater than 1 but less than infinity, it's elastic. And then finally, if it's equal to infinity, it's perfectly elastic. And so these are all tells us what the effect on revenues would be, as well as summarized in this table. So keeping this in mind, if you were a firm, would you rather face the elastic part of a demand curve or the inelastic part of a demand curve? Here are just some real-world examples of empirically estimating elasticities. So we've got cigarettes and how they differ in high and low-income countries. In low-income countries, we've got a higher elasticity of demand. Gasoline has a differing elasticity in the short term versus the long term because people are more able to change their behavior over longer periods of time. We'll talk about them more in the conclusion to this section. Air travel, soft drinks, eggs is just this kind of staple commodity. You can see that in the US, eggs probably make up a smaller proportion of people's household budgets, and so we have quite inelastic demand for eggs. But in South Africa, where they may make up a larger proportion of people's budgets, demand is relatively more elastic. And then we also have some price elasticities for rice in both Japan and China. And there's a similar argument there to the eggs of, in Japan, rice probably makes up a smaller proportion of people's household budgets than it does in China. We can also calculate sensitivities of sellers to changes in price, just like we can calculate sensitivity of demanders to changes in price. Alright, so we can calculate the elasticity of supply just like we can calculate the elasticity of demand, or the price elasticity of supply and the price elasticity of demand. We can drop the absolute values because they won't make any difference when it comes to supply, but you can also leave them on and it won't change anything. So let's go ahead and do one example on the supply side. So let's say that we want to calculate the elasticity of supply of this supply curve whenever we move from a price of 10 to a price of 5. So just like before, we want the percentage change in Q over the percentage change in P. I'm going to go ahead and drop the absolute values here for clarity or for simplicity's sake, but you could just as well keep them. So let's figure out the denominator of this. The percentage change in P is 5 minus 10 divided by 10. And the numerator is going to be 0 minus 50 over 50. Just cranking on from there. So 0 minus 50 is negative 50 over 50. 5 minus 10 over 10, so that's going to be negative 5 over 10. The negative signs will cancel out, so we can go ahead and not worry about that. And that will always be the case with supply curves. And that leaves us with 1 over 5 over 10. We can just take the reciprocal there, which is 10 over 5, which is equal to 2. So this is greater than 1, and just like with the demand curve, if E is greater than 1, we say that it is price elastic. There is another way of calculating the percentage change that is a little more accurate called the midpoint formula. And essentially all that does is it replaces the denominator in our percentage change equation with the average of the two values instead of one of the endpoints. I'm not going to generally ask you to do that throughout the course. I just want to make mention of it because it pops up in the textbook. But let's go ahead and do it for this example. So using the midpoint formula, all that's going to change about this is the denominators of each of these expressions. So which we're still going to have negative 50 over, but then we take the average, so it'd be 0 plus 50 divided by 2 in the denominator. And then we do the same thing for this one, so it's still going to be negative 5 over 10 plus 5 divided by 2. So the numerator ends up being, we'll go and get rid of the negative signs to keep things simple. Numerator ends up being 50 over 25, and the denominator ends up being 5 over 10 plus 5 is 15 divided by 2, so 15 over 2. Moving on from there, we've got 50 over, the fractions get kind of gross here, which is part of the reason why I'm not going to ask you to do this. 50 over 25 times 15 over 2 divided by 5. So that ends up being 50 times 15 over 2 over 50. We can multiply that by So 50 times 15 over 2 times the reciprocal of its denominator, which is 1 over 50, which makes the 50s cancel out, and we're left with 15 over 2. And so this is just one way of calculating elasticities in a little more exact way. I just wanted to make mention of it so you know what it was, but I'm not going to ask you to do that on any assignment. Having looked at both the demand side and the supply side, and how those interact with price, we can take a bit of a broader view now and think about there are factors other than price that affect people's behavior in markets. And one of those other factors is people's incomes. So we can calculate a bunch of different elasticities. We can calculate, because elasticity is essentially just a sensitivity to some changing variable. But we're just going to calculate the income elasticity of demand here as an example because it's a very useful one. So let's do a couple of examples of calculating income elasticity of demand. So first example here, suppose at an income of $10,000 you purchase one cell phone a year, but an income of $15,000 you purchase 2 cell phones a year. What is your income elasticity of demand for cell phones? And so this equation varies from our past equations by just a bit in the denominator. So we're still going to have this percentage change in Q in the numerator, but here we're going to have the percentage change in income in the denominator. And we must get rid of the absolute values for income elasticities. Otherwise, our results won't be possible to interpret. So, in this example here, our change in Q is the new value 2 minus the old value 1 divided by the old value 1. And the change in income is the new value 15,000 minus the old value 10,000 divided by the old value of 10,000. And just simplifying this all down, so 2 minus 1 is just 1, so we end up with 1 in the numerator. And here we've got 15,000 minus 10,000, so that's 5,000 over 10,000. Simplifying that, that's 1/2, 1 over 1/2, which is equal to 2. So unlike price elasticities of supply and demand, the critical point here isn't whether it's greater than or less than 1. The critical point here is whether it's positive or negative. And so this is greater than 0. And so what that tells us is that as our income increases, we consume more cell phones. We purchase more phones. And so that behavior tells us that in this example, cell phones are a normal good. But that isn't always going to be the case. So consider this example here. So suppose at an income of $100 you consume 1 bag of chips per week, and an income of $50 you consume 2 bags of chips per week. What is your income elasticity of demand for chips? So let's just calculate that out just like before. So the percentage elasticity with respect to income, so the percentage change in Q over the percentage change in M. So let's start with the change in income. So the new value, 50 minus the base value, 100, divided by the base value of 100. In the numerator, we've got the new value of chips, 2, minus the old value, divided by the old value. And so we end up with 1 in the numerator, which is nice and simple. In the denominator, we've got 50 minus 100 over 100. 50 minus 100, so it's negative 50 over 100, which is negative 1/2, 1 over negative 1/2, and finally we end up with negative 2 once we take the reciprocal and simplify. And this is critically less than 0. It's negative. And so that means that when your income falls, you actually consume more bags of chips in this example. And if that's the case, we say that that good is an inferior good. Good. Price elasticity of demand lets us approach this idea of normal goods and inferior goods. A normal good is just goods for which demand increases when incomes rise. So you have more income, you buy more of it. An example here might be shoes, right? And this is represented by a income elasticity of demand greater than 0. Once again, sign's important. It's positive. But there are also inferior goods, and these are goods for which demand decreases as your income rises. So that's a income elasticity of demand of less than 0. It's negative. And the classic example here is ramen noodles, right? Like the poor college student eats a ton of ramen noodles, but as their income rises, they may actually purchase rice or other forms of pasta or different food altogether. And so this is an example of how income changes consumption patterns. When a price increases, there are actually two things that happen. First is a substitution effect. So if, for instance, the price of apples increases, people may substitute to other similar goods. And, oranges, pears, what have you. The example I have here is the price of ebooks increases, so you switch to paper books. And so that's one effect of a price change. The other effect is the income effect. And so this is the fall in quantity demanded when the price for a good increases that results from a fall in real income. So in other words, if you spend a large proportion of your budget on gasoline, if the price of gasoline goes up and your demand for it is inelastic, you will feel relatively poorer because in real terms, your income has fallen because you can buy fewer goods and services than you previously could because gas is much more expensive and you still have to buy gas. So income goes up, you consume more normal goods, but fewer inferior goods. And so the substitution, the income effect, can be in opposite directions. And that brings us to the idea of a Giffen good. And a Giffen good is a very uncommon thing to happen in reality. And what's happening with a Giffen good is that the income effect is actually larger than the substitution effect, which is not typically going to be the case. Typically, whenever the price of a good increases, people are going to demand less of it. But with a Giffen good, it's the opposite. The price of the good goes up and people consume even more. And there are very, very few historical examples of this. The most famous one is potatoes in the Irish potato famine. In the images you see here, we've got the potato blight that actually caused the famine. And essentially, poor Irish families during the famine spent such a large proportion of their income on potatoes, and potatoes being an inferior good, because they would have much rather consumed other staples such as wheat. But when the price of potatoes went up, they felt so much poorer because such a proportion of their income was spent on potatoes that they actually had to increase their consumption of potatoes in response to the price increase. And this kind of paradoxical behavior is just incredibly strange. The monument at the top there was erected in Ireland as a thank you to the Choctaw tribe who had just experienced great starvation on the Trail of Tears just a few years prior to the Irish potato famine, and so the tribe donated a large amount of money to Ireland. Just kind of interesting historical background. But how does this tie into the rat experiments? Well, for a while, I believe in the 1970s, economics actually sought to replicate economic behavior in rats. And so they imposed prices for food on rats by essentially having them pull a lever. And so the number of times they had to pull the lever to get a food pellet was a price for food. And in these rat experiments, which in kind of a grotesque way verifies the historical evidence of the Irish potato famine, they were able to elicit Giffen good behavior for rats, but only whenever the price was so high that pulling the lever enough times to get a food pellet put the rats in real threat of starvation. rat experiments are not a staple in economics anymore, and this is clearly kind of a cruel experiment that we would definitely not do today. But like I said, in kind of this creepy, grotesque way, it kind of agrees and aligns with the historical evidence from the Irish potato famine. So, just to wrap things up, it's important to think about elasticities in time, because everything that we've looked at thus far, supply curves, demand curves, and elasticities, are looking at a single slice of time. And that's often the way economists like to think. We like to look at slice A of time and slice B of time and describe what's different. We don't really talk about the transition between. But it's important to think about the differences. So, short-run elasticity is a measure of the relatively immediate response to a price change, while long-run elasticity is a measure of the response to a price change after people have more time to make adjustments. A very classic example here is gasoline during the stagflation in the 1970s. For those of you who are not familiar, during the 1970s, OPEC embargoed or limited the supply of oil to the United States, which massively increased the price of gas. In the short term, people were stuck with the cars they had, and they tried to cut down, but they weren't able to change their consumption of gasoline all that much. But as time went on, people were able to trade in the kind of big gas guzzlers of the 70s for smaller cars, typically made in Japan, that were a lot more fuel efficient. And so the short-run elasticity for gasoline in the 70s could be said to be very inelastic, while the long-run elasticity, once people had a few years to adjust, was much more elastic. So, just to wrap things up, elasticities are, broadly speaking, just sensitivities of quantities to changes in other factors, such as prices or incomes, though it could be other variables. We looked at how to calculate a few of these common elasticities and how to interpret them. Elasticities in the real world can be estimated statistically, and so we looked at a few examples of those. Moving on to kind of where we talked about income elasticity, price increases have both an income and a substitution effect that could be in opposite directions, especially if the good is inferior. And finally, elasticities may differ between the long run and short run, and that's something we should keep in mind. So that's all I got for this week. Thanks.